Assalamu alaikum. Assalamu alaikum everybody. Can you guys hear me? Assalamu alaikum. Can you all hear me guys? Hi guys. What's up? Can you guys hear me? Yes? भाई आ गया हूँ. When is this going to start? I'm right here. Yes, I'm right here. Can somebody please just confirm that you guys can hear me? Yes. What's up? Oh my god, it's going crazy. Yes, okay, great. I'm audible. That's perfect. Chalo, I'm audible. That's good stuff. One second, let's pop this thing. How do we pop the questions out? Can we like pop out chat? Can we pop the chat out? Just give me a moment. Oh yes. Oh, love this. Chalo ji. Can everybody see the screen? Can everybody see the screen, guys? And can everybody also see me? Okay, great. Now, this is our first time conducting the ATP MasterClass through a YouTube live. So it's gonna be fun. You guys will inshallah enjoy it. Please don't go crazy in the chat. Let's just keep everything related to the chemistry ATP. I'm gonna give you guys some tips in order to start off with your ATP exam. How do you think during an ATP exam? And trust me, this is all you're gonna need inshallah to ace that ATP exam. You need to have a clear head first of all. Whenever you sit down for an ATP paper, you need to have a clear head. What that means is you need to have a good night's sleep. If you don't, then probably there are high chances that you get cooked during the ATP exam, because it's all about reading the question. Always read the question in ATP. That's the most important rule. How do you get 40 out of 40 in a paper? I'll teach it to you inshallah today. Turn on slow mode. What's slow mode? Slow mode is so people don't like spam chat. Chalo, inshallah, we are gonna fix. We are gonna get better at conducting lives, inshallah, soon, huh? Acha ji. Now, what are some tips that I'd love to give you? The first tip is always do graph questions towards the end. Always do graphs towards the end. That's the first, because just by getting the graphs neat and tidy and whatnot and drawing with pencils and then erasing it and drawing a smooth curve and not a smooth curve, it takes a lot of time. So do those graph questions towards the end. Number 2, test of ions should be on your fingertips. That's always a question that's always going to be tested. It's normally your question number 3. Test for ions, cations, anions, it's always going to be tested. And the last tip that I'm going to give you is read all the question. Read all the questions carefully. Carefully read every single question, and without further ado, let's just start off with solving the first past paper. I'm going to do 3 past papers inshallah. I'm going to do 3 past papers today in order to help you guys out in navigating your way through the ATP exam. Now also keep in mind, what are some chapters that you should revise for ATP. The first chapter that you should revise for ATP is rate of reaction. The second chapter is chemical energetics. The third chapter is moles and stoichiometry, or acid, base and salts. Acid, bases and salts. Wherever you learn, wherever you've learned, what's it called? Titration. That's the most important bits. And fourth, I'd also recommend revising, experimental chemistry, in which you should most probably revise chromatography or chromatography, whatever. Now without further ado, let's just start solving questions and you're going to get an idea of how the ATP paper is going to be solved. Okay, now I'm going to start off with an O-level IGCSE paper, an O-level paper which is 507041, and then I'm going to start off with the IGCSE paper and all of that. The idea is to help you guys navigate your way so that you guys can easily solve any ATP paper that's thrown towards you, right? Chalo, without further ado, let's just start solving question number 1 for 507041 May June 2025. My name is Suleiman Khan, like Abishas say, and let's start solving. Okay, now let's solve. Now question number 1 says a student determines the solubility of solid ammonium chloride. Now ammonium chloride is NH4Cl. Solid means it's a solid, particles are tightly packed and whatnot, and he's saying he wants to determine the solubility in water at 60 degrees Celsius. So the moment you read questions like this, your thought process should start to tell you कि अच्छा, if you need to have 60 degrees Celsius, what do you need to do? You need to heat it till 60 degrees Celsius, don't you? Heat it till 60 degrees Celsius. You need to ensure it. And how would you ensure that it's heated till 60 degrees Celsius? Well, you require a thermometer for it. That's how easy you start to think. Okay, this is how your thought process starts to work. So he says he puts 100 cm cube of water into a beaker. Great stuff. He heats the water up and then he measures the mass of a weighing bottle containing ammonium chloride. Now the problem is that he heated the water, but he did not figure out the temperature of water, because he wants to figure out the solubility of ammonium chloride at 60. So what he should do is he should heat the water till 60 degrees Celsius. So what should he do? He should measure the temperature to ensure that water is at 60 degree Celsius, everybody, right? So what should he do here? I'd say please measure the temperature. This is what should go into your brains, right? Measure the temp to ensure that it's 60 degrees Celsius, because you want to figure out the solubility at 60. So also ensure that it's at 60. Okay, this is measure the mass of weighing bottle containing ammonium chloride. Add some of this ammonium chloride to water. So now what he is doing is imagine it. You need to imagine it. You need to visualize it. So he started to add some ammonium chloride to water, and what became of it? He added it. He stirs the mixture to dissolve the solid. Now there are two reasons why he's stirring the mixture: to ensure that all of the or a single reason, to ensure that all of ammonium chloride is dissolved in water, right? To ensure the maximum amount is dissolved. That's what he wants to ensure. Now he says stirs the mixture to dissolve the solid. Great stuff. And then he's saying repeat step 4 and 5 until a small amount of undissolved solid remains in the beaker. So he started off by adding ammonium chloride to the beaker, and then he heated it till 60 degrees Celsius, which he has not mentioned, so I mentioned it for him. And then he heated it, some of the undissolved solid remained, right? And then he says he measures the mass of the weighing bottle and unused ammonium chloride, and then he calculates the mass of ammonium chloride added to the water. Great. Now he says state one extra measurements that the student must make to calculate the solubility. What measurement should he do? Well, obviously, because the student wants to figure out the solubility at 60 degrees Celsius, he needs to measure the initial temperature, or he needs to measure the temperature when he heats up the water. He needs to measure the temperature. Yeah, this should be at 60 degrees Celsius. So what should he do? Bataiye. Yes, he should measure the temperature to ensure. So I'll write it here even. He should measure the temperature to ensure that he should measure the temperature of water, obviously, to ensure that it is at 60 degrees Celsius. It's very basic. It's very common sense wali baatein. It's very common sense wali baatein, right? Yes, he should. One extra. No, so he's not saying, acha, wait a moment. Some students are saying, sir, he should use a thermometer. What should he use a thermometer for? To bang his head against it, right? No, making a use of thermometer is not a measurement. He's saying what measurement should he take? So he should measure something. He's not saying what should he use to measure it. He should measure the temperature. So the measurement is temperature. Yeah. That's very important. Sir, why not measure mass? Because he's already measured the mass right here. He weighs the bottle. So he's already measured the mass, right? Now it says the student's result are shown. Initial mass in step 3, which is 173.7. In step 3, it was the mass of the bottle containing ammonium chloride. And the step 7 mass is 115.5, which is what? Which is the mass of the unused ammonium chloride. Now there's a problem here. Let me tell you what the problem is, everybody. The problem is that this method is incorrect. I'll tell you why it's incorrect. See, when you started off with ammonium chloride and you added ammonium chloride to it, initial mass in step 3, which was about 173.7 grams, right? And when you added ammonium chloride to it, now after mixing it and whatnot, what happened was that you have a solution in which weighs about what? 115.5. Sorry, you have the weighing bottle. Sorry, the weighing bottle now has 115.5 grams, but he's also measured unused ammonium chloride, right? Unused ammonium chloride का मतलब है इसमें कुछ specks are remaining. There are some specks of ammonium chloride remaining, and this is an incorrect method. Why? Because you can't figure out solubility like this. You should remove this solid from it so that you can properly figure out the solubility. Because at 60 degrees Celsius, if you want to figure out कि यार अमोनियम क्लोराइड कितना डिसॉल्व हो चुका है at 60 degrees Celsius, you should remove the excess ammonium chloride out of it, shouldn't you? So this value is effectively overstated. So he says use the result to calculate the solubility at 60 degrees Celsius in gram per dm cube. So what is the solubility? What you do is you take the final reading, the initial reading, and subtract the initial and final reading, take the difference between the two. What do you get? इतना ammonium chloride dissolve हो गया, right? 115.5. How much mass of ammonium chloride has dissolved? How much mass? 58.2 grams. This is the mass of ammonium chloride dissolved. Done. But he's saying figure it out in gram per dm cube. Now 1 dm cube contains 1000 cm cube, and this experiment is carried out at what mass? At which volume of water? It's carried out at 100 cm cube. So this many grams of ammonium chloride dissolved at 100 cm cube. तो 1000 cm cube पे कितना ammonium chloride dissolve होगा? X cross multiply, what do you get? 58.2, because 1000 cm cube is effectively 1 dm cube, right? So 58.2 times it by 1000 divided by what? Divided by 100. Cross multiply, right? 100 ones are 100, 100 tens are 1000. 58.2 times by 10, what do you get? What do you get? जी बताइएगा, कोई बता दें यार. 582 gram per dm cube. Which paper is this? This is 507041 May June 2025. Now keep this in mind. There's a problem with this experiment. What's the problem? What's the problem with this experiment? Some of the solid remains. That's what he's saying. He's adding ammonium chloride to water, he's stirring it so the solid dissolves, and he's saying he repeats step 4 and 5 until a small amount of undissolved solid remains. So this is not a proper way to figure out the solubility of ammonium chloride, because some of it remains undissolved, right? So you need to make sure either remove the undissolved bit and then take the difference. Then it's the correct method. You remove the undissolved bit and that'll tell you kitna ammonium chloride dissolve ho gaya, right? You remove the undissolved bit from it. But you've not done that. So the problem is, and he is asking you this, explain why the method that the student uses gives a higher value for the solubility rather than the true value. It's a higher value because when you took the difference in solubility is higher. Why? Because some of the solid has not dissolved and you've taken it in the difference, right? So yes, you tell the examiner, explain it. Well, examiner, some of the solid, that is ammonium chloride, has not dissolved, right? So the value is overstated. He is effectively saying यार जो undissolved bit भी है वो भी dissolve हो गया. That's what he's doing. My voice is too high, let me slow it down. If my voice is too high, let me slow it down. Wait. If my voice is too high, I'll slow it down. I hope it's fine now, huh? अब सही है? Is my voice fine now? Is my voice fine? Is it fine now, guys? Great. Next. वो कह रहे हैं कि जनाब the student repeats the experiment at different temperatures. So he's repeating the experiment at different temperatures. Sir, why did you do initial and final ka difference? How did 100 come from? Oh my god. Please listen. 100 cm cube is given in the question. 100 cm cube ye hai, pours 100 cm cube into water, of water into a beaker, and then he adds ammonium chloride to it. So the solubility of ammonium chloride is given for 100 cm cube. He wants it for 1 dm cube, which is 1000 cm cube. So for these many grams of ammonium chloride were for 100 cm cube. So for 1000, how many what was the mass of ammonium chloride? X. Cross multiply, that's for 1000 cm cube, which is effectively 1 dm cube. Yeah? Great. Sir, voice is too low now. Okay, great. Voice is too low, too high. What's going on? Let's fix the voice. Wait. Okay, let's increase it now. Okay, chalo, bas sahi hai. Your voice is too low, let me increase it. Chalo, bas? Happy? Chalo ji. Done? Now, please listen. Listen. Acha, I've increased the volume. Now it says the student repeats the experiment at different temperatures. The results are shown in table 1.2. He's given you the temperature in degrees Celsius and he's given you solubility, right? Now it says estimate the solubility at 20 degree Celsius. What you need to understand is that at 40 degrees Celsius, the solubility was how much of this guy dissolved. Now, the difference between 0 to 40, that's 40, right? So, in दोनों के बीच में difference कितना है? 480 and 300. At 40 degrees Celsius, 180 grams of ammonium chloride had dissolved. 180 grams extra, right? At 0, there were 300 grams in 1 liter, but at 40 now there's 480. तो 40 डिग्री सेल्सियस का चेंज में कितना चेंज सॉल्युबिलिटी में आया? 180 ग्राम सॉल्युबिलिटी में चेंज आया, isn't it? 180 ग्राम is the change. हाँ जी, 180 ग्राम is the change for 40. And इस 40 में कितना चेंज है? इस 40 में कितना चेंज है? 40 to 80 कितना चेंज आ रहा है? 660 और 480 में व्हाट्स द डिफरेंस? 660 minus 480, that's again a difference of 180 grams, isn't it? अब वो कह रहे हैं एस्टिमेट करें कि 20 grams पे solubility कितनी होगी. What would be the solubility at 20 grams? How are you estimating? हाँ जी. Sir, bro likes the word 14. How are you guys estimating? How is 390 coming about? जी बताइएगा 390 कैसे आ रहा है? सबर करें, ये जो मार्क्सीन से पढ़ के बोल रहे होते हैं, जी बताएं 390 कैसे आ रहा है? Suggest why the method used for ammonium chloride is obviously because ammonia is a gas. Ammonia जनाब एक गैस है. Ammonia is a gas. How can you weigh a gas? He's saying he wants to use the same method for a gas, right? So how is ammonia a gas? How can you weigh ammonia? Ammonia is a gas. You can't do that for it, right? So you cannot do this for ammonia as it is a gas. Done? Okay. Next, solid A is impure calcium carbonate. Impure calcium carbonate, CaCO3. Done? Lekin it also has other substances. CaCO3 plus other substances, obviously. Okay. Now, you need to understand that he's saying a student determines the number of moles of calcium carbonate in sample of A. Achha. The student places a sample of A into a beaker, uses a measuring cylinder to add 100 cm cube of 0.250 mole per dm cube of hydrochloric acid. Measuring cylinder इस्तेमाल करना चाहिए. It should click in your brain that measuring cylinder is less accurate. What should he use? He shouldn't use a pipette, guys. ही शुडंट यूज ए पिपेट. वाई? पिपेट तो आपके लिए करता ही 25 cm क्यूब है आपके कोर्स में, इजंट इट? पिपेट तो आपके कोर्स में 25 cm क्यूब ही करता है. तो हमें क्या करना चाहिए? हमें वी शुड यूज ब्यूरेट, shouldn't we? We shouldn't use pipette, we should use burette. Why not pipette? Because pipette करता ही 25 cm क्यूब है, ऐसे ही है. तो या ब्यूरेट इस्तेमाल करें मेजरिंग, और या मेजरिंग सिलेंडर इस्तेमाल करें. Now he's saying कि यार he places A into the beaker. Now calcium carbonate, keep this in mind, it's a weak base. That's also something that should come into your brains कि यार calcium carbonate तो एक weak base है. Now he's saying he adds it to hydrochloric acid and he stirs the mixture until no more effervescence is seen. But you need to understand that since calcium carbonate is a base, it will react with hydrochloric acid. What would it give you? It will give you calcium chloride plus H2O plus CO2. So he's saying that he's adding hydrochloric acid to the beaker and until no more effervescence is observed, which means that all the acid is used up. All acid is used up. Okay. As in, calculate the number of moles of HCl added to the beaker. He's given you the volume of HCl. He's given you the concentration. What do? N equals CV. N equals CV. Moles कितने हैं निकालने? Concentration is what? 0.250 into volume, which is what? Volume is in cm cube converted into dm cube. What do? 100 divided by 8000. Why? Because 1 dm cube equals 8000 cm cube. तो अगर मेरे पास जनाब वाला 100 cm क्यूब होंगे तो कितना dm क्यूब होगा? x क्रॉस मल्टीप्लाई, व्हाट यू गेट? x equals 100 divided by 1000. That's how we do it. Okay. I explain it towards the end. Solubility, I'll explain it towards the end again. Don't worry. I'll explain Zoha. I'll explain it towards the end again. Don't worry. Solubility. Oh, sorry. Yes, solubility increases. क्या? Decreases at lower temperatures. Yes, thank you. Solubility decrease करती है ना lower temperatures पे. You're absolutely right. I meant to say decreases at lower temperatures. टेम्परेचर में जितना कमी होगी उतनी solubility कम हो जाएगी ना. तो टेम्परेचर आपने कम किया, solubility 180 से कम हो जाए, 180 पे हाफ हो जाएगी 90. तो 480, 40 डिग्री सेल्सियस पे 480 है, 90 सब्ट्रैक्ट कर लें 390. वाई? बिकॉज 90 ग्राम्स कम soluble होगा ना, राइट. Solubility decreases at lower temperatures. Sorry, increases गलत बोल रहा था, decreases है. या बोलना मुझे decreases कहना चाहिए, increases बोला है. ठीक है? I hope it's clear now, right? The sentence is this: soluble solids tend to become less soluble at lower temperatures. Yeah? Done? So अगर they tend to become less soluble, that means 480 अगर है, आपने टेम्परेचर आधा कर दिया तो solubility 180 का डिफरेंस, आधे से इसको कम करें 90, 480 minus 90. Okay? Slip of tongue, very big slip of tongue. N equals क्या आ रहा है जनाब? जी बताइए. What do you get N as? बताएं कोई मदद करें यार, कोई मदद करें. N equals zero point zero two five moles. Done. I think the student rinses a burette with water and then with 0.1. Oh my god, this is a beautiful question. The student rinses a burette with water and then he rinses it with sodium hydroxide, right? Now look at what he's doing. He first added acid to calcium carbonate. It also had other substances, I don't care, but this would have been the reaction. And he's saying he added calcium acid until all the acid was used up, because that's when there's going to be no more effervescence. And then he's rinsing the burette with water and then he's rinsing it with NaOH. Why? Because if you rinse the burette with water, there will be water droplets in it, wouldn't they? Now you can't put a kapda inside it to clean it. The opening is pretty small. So what you do is you wash it with NaOH again. Why? Because if you don't wash it with NaOH and you just wash it with distilled water and then pour NaOH into it, what will happen is it'll dilute NaOH for you. It'll dilute NaOH. And what that would mean is that volume of neutralization, volume for endpoint, that'll be higher, it'll be overstated than in reality, क्योंकि अगर ये डाइल्यूट हो गया तो इसका ज़्यादा वॉल्यूम इस्तेमाल होगा. If the NaOH becomes diluted, इसका ज़्यादा वॉल्यूम इस्तेमाल होगा जो कि असल में नहीं होना चाहिए. ये 0.1 मोल पर डी एम क्यूब इसकी कॉन्सेंट्रेशन है. अगर इसमें कुछ वाटर ड्रॉपलेट्स होंगे ये डाइल्यूट हो जाएगा, इसकी कॉन्सेंट्रेशन कम हो जाएगी तो इसका वॉल्यूम ज़्यादा इस्तेमाल होगा. ओके, समथिंग टू कीप इन माइंड. ठीक है जनाब. अच्छा, तो इसने NaOH डाल दिया एंड ही सेइंग कि he fills it now and he's saying he adds 25 cm cube of B and 5 drops of methyl orange indicator to the conical flask. B क्या बला है? B क्या बला है? B क्या बला है? B में आपके पास ये सारी चीज़ें मौजूद हैं. कैल्शियम क्लोराइड होना चाहिए, एक्वस कैल्शियम क्लोराइड होना चाहिए और क्या कुछ. राइट नाउ सर डाइल्यूशन, सो रिंस विद या व्हाटएवर. खैर, इनिशियल वॉल्यूम है, टाइट्रेशन कर रहा है, फाइनल वॉल्यूम है और उसने बी को डाला हुआ है एंड ही एडेड 5 ड्रॉप्स ऑफ methyl orange to the indicator. Now what are the colors for methyl orange? Methyl orange gives you a yellow color for an alkali and a red color in an acid. I see. Now what's going to happen is he's saying he repeats this titration 2 more times and shows the initial and final burette reading for titration 1. So what is the initial reading? 2, 2.1, 2, 3, 4, 2.4 है. इधर आ जाए. इनिशियल रीडिंग क्या है? 2.4 है टाइट्रेशन 1 की. फाइनल रीडिंग क्या है? देखिए जाओ, देखिएगा. व्हाट इज द फाइनल रीडिंग? 18, 18.1 राइट हियर. 18.1. What is the volume used in all these cases? Final minus initial. Final माइनस इनिशियल. जी, कितना वॉल्यूम इस्तेमाल हुआ? फाइनल माइनस इनिशियल. 15.7 cm क्यूब हियर, देन 15.2, then 15.4. Done. Now he's saying what are the best titration results? Remember, the best titration results are concordant results. Concordant results क्या होते हैं? Concordant results वो होते हैं which are within 0.2 cm cube of each other. और आपके कोर्स में आपको बताता चलूँ कि concordant results वो होंगे आपके कोर्स में जो दो वैल्यूज़ आपस में सबसे करीब हों. जो दो वैल्यूज सबसे करीब हों उसको हम क्या कहेंगे? कॉन्कॉर्डेंट रिजल्ट्स कहेंगे. द वैल्यूज विच आर क्लोजेस्ट टू ईच अदर, द रियलिटी इज विच आर विद इन 0.2 cm क्यूब ऑफ ईच अदर, और या आप कह सकते हैं विच आर क्लोजेस्ट टू ईच अदर. सो इट इज व्हाट 15.2 एंड 15.4, दीज आर विद इन 0.2 cm क्यूब ऑफ ईच अदर. सो दीज आर द कॉन्कॉर्डेंट रिजल्ट्स. नाउ सी, यूज द टाइट्रेशन रिजल्ट्स टू कैलकुलेट द एवरेज वॉल्यूम ऑफ NaOH, द बेस्ट टाइट्रेशन रिजल्ट्स, which is what 15.2 and 15.4. How do you calculate the average? Divide by 2. What do you get? 15.3. So 15.3 cm cube मेरा NaOH है. अब कह रहे हैं the acid used in A to prepare mixture B is in excess. Oh, so what he's saying is कि जो acid हमने इस्तेमाल किया था इधर to prepare B, इसमें acid मौजूद है. इसमें acid भी मौजूद है which probably does not make which probably goes on to show you कि यार calcium carbonate जो है, this was the guy which got used up. So not all here, from here we realize कि acid was in excess and it was calcium carbonate which was used up. और इसमें और कोई ऐसी चीज़ नहीं होगी जो एसिड के साथ रिएक्ट करती होगी probably. ठीक है, तो ये चीज़ें जो हमें रियलाइज़ होते हैं कि हम जैसे जैसे सवाल करते जाते हैं तो वी रियलाइज कि अच्छा एसिड जनाबे वाला, इसमें एसिड भी मौजूद है. इसीलिए तो दैट इज द रीजन व्हाई इट रिएक्टेड विद alkali. And what should be the color of the solution in the conical flask when you added methyl orange to it? Well, obviously it should be red, because we now know okay, it was the acid that was in excess. Done. Now he's saying use the answer to B part 2 to calculate the number of moles present in these. So you're given the volume of NaOH used, you're given the concentration. What do we do? N equals Cv, the most fun formula to use. मोल्स निकाले, कॉन्सेंट्रेशन कितनी है 0.1, वॉल्यूम कितना है 15.3 बट डिवाइडेड बाय 1000. व्हाई? बिकॉज इट्स इन cm cube and he wants the moles, right? He wants the moles. So 15.3 divided by 1000. What do you get? 15.3 divided by 1000 and multiplied by 0.1. आपको इतना कैसे पता? I'll post this later. चलो ठीक है, क्या आ रहा है, क्या वैल्यू आ रही है? 0.00153. 0.00153. These are the moles. These are the moles of NaOH. Done? And these are the moles of NaOH that reacted with 25 cm cube of B. 25 cm cube of acid effectively. Done. Now I think calculate the number of moles of NaOH that would react with 100 cm cube of acid. Now if you had 0.0153 moles to react with 25 cm cube of acid, तो 100 cm cube of acid के लिए कितना moles required होगा? X cross multiply, what do you get? G, what do you get? Cross multiply, what do you get? यार आप रिकॉर्डिंग देख सकते हैं, आप दोबारा रिकॉर्डिंग देख सकते हैं जी. You get 0.00612. Let's also confirm it. Okay, 0.00153 times by 4. Yep, that's it. 15.3 वॉल्यूम कैसे आया इधर? एवरेज वॉल्यूम, ये NaOH का वॉल्यूम. सी द टिप दैट आई गिव यू इज कि आप देखा करें कि आप फाइंड क्या करें. यू फिगर आउट द वॉल्यूम ऑफ NaOH, यू आर गिवन द कॉन्सेंट्रेशन ऑफ NaOH, N equals C. वी फिगर आउट द मोल्स ऑफ NaOH रिक्वायर्ड टू न्यूट्रलाइज 25 cm cube of B. अब वो कह रहे कितने मोल 100 cm cube of B को न्यूट्रलाइज करेगा. फॉर 25 cm cube, if these many moles were required, for 100 what would be required? X, you cross multiply, get the moles. Right? Next, he says the answer to D right here, these moles of NaOH, the answer to D is equal to the number of moles of HCl that remain in the beaker after the acid reacts with calcium carbonate in sample A, which means that 0.00612 moles are excess. These are the excess moles of the acid. That's why he's saying कि इतने मोल्स जो हैं ये रिमेन कर रहे हैं. तो रिएक्ट कितने ने किया? How many moles of acid did you have initially? How many moles of acid did we have? Right here, these were the moles of acid that I figured out. Moles of acid. मेरे पास moles of acid ये थे और remaining कितने हैं? I had 0.025 moles of acid and the remaining moles of acid are 0.00612. ये remaining है. तो reaction कितने moles of acid ने किया है? How many moles of acid did react? Initial moles जितने थे और remaining जितने, इनका difference इतने react कर गए हैं, which is what? 0.0189. 0.0189. These are the moles. We are also going to do IGCSE. Okay. Then we're also going to do IGCSE. Relax. We'll do O-level IGCSE, both papers. Done. Now he's saying the equation for the reaction between hydrochloric acid and calcium carbonate is shown. Calculate the number of moles of calcium carbonate in the sample of A. अब A आपके पास क्या है? A sample में आपको पता चला कि these were the moles of hydrochloric acid that reacted. How many moles of hydrochloric acid reacted? 0.0189 moles. These were the moles of HCl that reacted. अब हमने क्या करना है? First step is to figure out the moles of HCl. Next step, use the balanced equation to figure out the moles of calcium chloride. You know that HCl and calcium chloride किस ratio में react करते हैं? 2 moles of HCl react with 1 mole of calcium chloride. Sorry, calcium carbonate. So if you have 0.0189 moles of HCl, how many moles of calcium carbonate would it react with? N equals 0.0189 over 2. What do you get? It's not even chemistry at this point. Yes, it's just basic math. What do you get? Why did you subtract? I subtracted because understand that the initial moles of hydrochloric acid that I had was this much. And he's saying कि जो moles आपने D में figure out किए हैं, these are the moles which were in excess. these are the moles of hydrochloric acid that were in excess, which means ये remain करते हैं. Out of this is what remains. So the difference of these two should be the hydrochloric acid that reacted. और फिर उसी के बाद मैंने कहा कि जी इतने moles of hydrochloric acid react कर गए, 2 reacts with 1, so इतने moles of hydrochloric acid अगर react किए तो कितने moles of calcium carbonate के साथ react कर गए होंगे. And cross multiply, what do you get? 0.00944. 0.00944 and 955. 945 or 94. मैं करूं? Okay. I'll do it as well. It's 0.994, it's 9.44 into 10 is power minus 3. Now please keep this in mind, guys. What you guys are doing is you guys are writing this in the calculator and then pressing divide by 2. This is incorrect. Whatever value you get from this place, I just rounded it off. I think you guys told me the rounded value. This is 0.01888, right? So we rounded 18 off to 9, but we're still going to use the value that's plugged in right here in the calculator. So जो value calculator में होगी उसी को आपने divide by 2 कर देना है. Please divide by 2 the value that's given in the calculator, not the rounded value. You can write the rounded value in the exam, but use the values given in the calculator, please. Okay, so it is 0.0189 divided by 2, but we are using the calculator value, which is what? It is 0.00944. Yeah, 0.00944. Yeah. Okay. In a mixture in A, the mixture of A and acid is stirred until effervescence stops. Give a reason for mixing the reactants by stirring. Why would you mix the reactants? So that they react quicker. So that they react quicker. Okay. Then give a reason for waiting for the effervescence to stop. Why would we want the effervescence to stop? So that all the calcium carbonate has reacted. Because see, initially we thought that the acid was the calcium carbonate was in excess and the acid was limiting. But what he has done is he has made sure that all the calcium carbonate reacts. That's why hydrochloric acid was in excess, and that's why you still had moles of hydrochloric acid in the conical flask, and that's why it reacted with NaOH and all of that good stuff. Right? And what would be the color change of methyl orange? It'll go from red to yellow probably. Yeah, because conical flask में तो acid पड़ा था ना. So what is the reason? To ensure that all calcium carbonate is used up. All calcium carbonate is reacted. Done? In a measuring cylinder is used to add 100 cm cube of 0.250 mole per dm cube of hydrochloric acid to the beaker. Explain why using the measuring cylinder makes the volume of HCl. Oh, this is a very good question, guys. Very good question. Why is measuring cylinder inaccurate? Why? And what is the improvement? What is the improvement? Why is it inaccurate or improvement क्या है? जी, it's better to use a pipette. A burette. Pipette, normally आपके course में the pipettes in your course are, what do you mean reacted quickly? Because you're stirring it na. So if you stir it, you want them to dissolve quicker or to react quicker, whatever you write, dissolve quicker, react quicker, whatever, right? So you realize कि अच्छा इस case में you can either use a burette or a pipette. The real apparatus to use here, what I think, is the burette. Why? Because normally in your course, जो आपके पास course में pipette होता है, that's only 25 cm cube. So I'd prefer using a burette. And why do you not use a measuring cylinder? Now he's saying explain why. You can't say it's inaccurate. वो तो उसने भी बता दिया. Why is it inaccurate? Why? Because measuring cylinder 2 dp तक read करता है. Whereas a burette, a burette reads to 2 dp, whereas a measuring cylinder only reads till 1 dp. Or you could say it does not have a high resolution. True, that's also true. So you could say the measuring cylinder measures, उसकी accuracy इतनी नहीं होती ना. Cylinder measures till measures till 1 dp only, versus burette that is, which is 2 dp. So it's less accurate compared to burette. Okay, तो बस 100 लिखने की ज़रूरत नहीं है, बस ठीक है. Sir, you can also use the burette 4 times as the pipette 4 times. Sure, you could do whatever you want. I just said that using a burette is better. Sir, can we write to dissolve calcium carbonate? That's also correct. You could also say to dissolve calcium carbonate. That's also true. To make them react quicker or to dissolve them, because the moment you stir, the more in contact it will come with the acid. dp is decimal points or decimal places. Next, he's saying in B, the burette is rinsed with water and then NaOH is added. Why is the and then with NaOH? So first he rinses it with water and then with NaOH. Why? Because he does not want the NaOH to be diluted. So what happens? This prevents the NaOH to be diluted. If it is diluted, then a higher volume of NaOH would be required. Would be used. Or a higher volume of neutralization of NaOH would be recorded, right? But that is the overstated value, which is going to be overstated value. Right? Overstated volume लिख सकते हैं value की जगह. To avoid dilution of NaOH, yes, I already explained it, Ishal. If you've seen this, why do I explain it right about where did it go? I explained it right here, Ishal. Right here. Why are you Heisenberg of Pakistan? खुदा को खौफ करें. अच्छा, a student tests two aqueous solutions W and X. The student adds aqueous chlorine to W and concludes that W contains iodide ions. Oh, you know a reaction. Chlorine reacts with, let's suppose W also had potassium, right? Remember this reaction, the displacement reaction. It should directly click in your brain. Chlorine plus potassium iodide. What should it give you? It gives me KCl plus iodine. Remember? Potassium iodide ions are reducing agents. Even though we don't know whether potassium ions are there or not, I'm just saying if iodide ions are there, it will form chlorine since it's more reactive than iodine. Therefore, it will displace iodine from its salt solution, giving you as I2. And I2 aqueous is brown. It's a brown solution. Sometimes examiner also tends to write black, because iodine solid is black and iodine quickly also solidifies, right? So this is the reaction that you should know. And he's saying he concludes that there are iodide ions. Probably he must have added silver ions to it, because every time you add silver nitrate, silver ions plus iodide ions gives you a pale yellow PPT. AgI solid banta hai na? Makes sense. Now he's saying describe the observation that the student makes that leads to this conclusion. Explain how this shows that W contains iodide ions. This is a good question. Ji, batayega, how does it tell you that W contains iodide ions? Because there is a displacement reaction with chlorine, right? So you say, hey, chlorine displaces iodine from its salt solution. Done? Or you could say there's a displacement reaction with chlorine. And what would be the observation? You'd go into a brown solution would be observed. A red brown solution brown solution. This guy is colorless, by the way. This guy is colorless. So but if it were potassium, now we don't know which ions are present. We don't know whether there are potassium ions or not. So we are just going to say I2 aqueous banna hai. So a brown solution is seen, is observed or seen. Red brown likh le, whatever. I2 aqueous is brown. Describe another test and observation that confirms that W contains iodide ions. How can you confirm halide ions? How do you confirm halide ions? You add dilute nitric acid, acidify with dilute nitric acid, and add silver nitrate. Right? This is also given at the back of the table. So when you add silver nitrate, what happens? Silver ions, they come into contact with I- ions and forms AgI, which is a pale yellow PPT. Isn't it? And the reason why AgI solidifies is because all halides are soluble except for lead, mercury and silver, and we tend to use silver ions to our advantage. So the moment silver ions come into contact with the iodide ions, it forms AgI solid, which is a pale yellow PPT. So you say a pale yellow PPT नहीं लिखना एग्जाम में, precipitate लिखना है. Precipitate forms. Done? Now I think describe another test and the observation that confirms that W ions. अच्छा ये तो हो गए हैं. The student does a flame test on W and observes lilac flame. What is lilac? मैंने आपको बता दिया lilac flame तो कर रहे हैं, इसका मतलब potassium ions है. Our guess was even right. I was just giving you guys an example here, but lilac flame is because of the potassium ions. Therefore, the W is what? Potassium iodide. Ki, isn't it? And he says describe how he does the flame test on W. Now since W is an aqueous solution, see it's not a solid, he's saying it's a solution. So what you do is you dip a nichrome wire in the solution, dip nichrome, it's a 2-mark question, so dip nichrome wire, a clean nichrome wire, a clean लिख लेते हैं, or you could clean in concentrated hydrochloric acid. So dip a clean nichrome wire in the solution, or dip a splint in the solution, and then what happens? Place it at the edge of the roaring blue Bunsen flame. The roaring blue Bunsen flame. Blue flame of the Bunsen burner. And observe the lilac color. And observe color of flame, which in this case is lilac. Thank you, Muhammad Yahan is saying we love you. Sir, how did we understood that it's agar solid hota, then you would place a sample of solid on nichrome wire. You wouldn't dip it in the solid, you would place some solid on the nichrome wire. Right? Sir, why was Chem V2 P4? No, it wasn't difficult. I saw the paper, yaar. Chemistry IGCSE was halwa. Kya kare? But if it was difficult for a lot of students, then the threshold would be low, but it was pretty easy. Absolutely. Yeah, you could dip it in, you could obviously dip it in conch hydrochloric acid to clean it. ठीक है जी? नहीं, why wouldn't we use glass rod? देखिए, you either use a nichrome wire or you just write wire or you write a splint. And the reason for that is pretty simple, is because a lot of things are going to give you, पहले तो glass rod तो वो तो इसके temperature ही withstand नहीं कर पाएगा Bunsen burner का, number 1. Number 2 ये है कि if you use any other metal, all substances normally show characteristic flame colors, right? Sir, in the marking scheme they write PPT. No, you have to write precipitate, full words. Okay, so that's one thing. तो वो flame color तो nichrome wire का कोई अपना flame color नहीं होता. It does not have any characteristic flame color, hence we use it. अच्छा, X contains one anion and one cation. The student adds aqueous sodium hydroxide. अच्छा, एक anion है, एक cation है. He's adding aqueous sodium hydroxide in the test tube. He warms the mixture. So he added NaOH plus heat or warm. What is this a test for, by the way? NaOH plus heat is a test for ammonium ion. See, these things should be on your fingertips. And when would it have been the test for nitrate ions? If you also added aluminum to it. So if you just add NaOH and heat, this is a test for ammonium ion, and if you also added aluminum to it, then it would have been the test for nitrate ion. So with ammonium ion, it also gives ammonia gas, and with nitrate ion it also gives ammonia gas, but it would have only been the test with nitrate ion if aluminum were to be added. Now he's saying add aqueous sodium hydroxide to X in a test tube, warms the mixture, holds a piece of red damp, and obviously ammonia gas turns damp red litmus paper blue. So he's saying a white PPT soluble in excess, a white PPT forms which is soluble in excess sodium hydroxide. You know that white PPTs in your course either form with aluminum 3 plus ion, zinc 2 plus ion, or with calcium 2 plus ions, because these are not transition metal ions. With sodium hydroxide, they all form white PPT, white PPT, white PPT, but calcium ions are insoluble, which means the white PPT remains. These guys are soluble and soluble, and then what happens is, since zinc 2 plus is a Muslim pro max, it's not a munafiq, it'll remain the same, so it'll give you white PPT and soluble even in aqueous ammonia. Right here in excess aqueous ammonia will be soluble, but aluminum on the other hand, it's the munafiq ibn munafiqun, he's gonna become insoluble. So aluminum ke saath, aluminum ions, they will give you with excess ammonia they will turn insoluble, which means the white PPT will remain. Now I think the litmus paper does not change color. If it does not change color, that means there are no ammonium ions. So no ammonium ions, right? And it's either the zinc 2 plus ion or the aluminum 3 plus ion, because these guys will give you white PPT, and in excess they will form a solution, a colorless solution, which means they'll be soluble in excess. Right? So state 3 conclusions that are made from these observations. What are the 3 conclusions? 3 conclusion is there is no ammonium ion, number 1. Number 2, there is the cation is either aluminum 3 plus or zinc 2 plus. Done. It can't be calcium 2 plus because calcium is insoluble. Done. Then the conclusions in D identify cations that may be present in X. Okay. Describe another test that the student does to identify the cation in X. Now you're confused. He's saying it's either aluminum ion or zinc 2 plus ion. What's the other test? Well, you add aqueous ammonia to it. So you say add excess aqueous ammonia. Right? What happens in excess aqueous ammonia? बताइए. Or you could say add aqueous ammonia. You could say add टेस्ट में बस सिर्फ ये लिखना है add aqueous ammonia till in excess, ऐसे करके लिख लें. Done. So what happens? White PPT forms. PPT नहीं लिखना आप लोगों ने, प्लीज. यू आर नॉट सपोज टू राइट PPT, प्लीज. आपने प्रेसिपिटेट लिखना है. White PPT forms which is insoluble in excess, और ऐसे करके लिख ले. White PPT forms insoluble in excess. इसका मतलब क्या होगा कि एल्यूमिनम आयंस मौजूद हैं. एंड इफ white PPT forms but soluble in excess, that means कि zinc 2 plus ions मौजूद है. Right? Sir, calcium ions form slight white PPT. They do, but the problem is they either form no PPT, but with excess aqueous ammonia they do form a very slight white PPT. But the problem is that calcium ions are insoluble in sodium hydroxide, whereas the examiner said that in excess sodium hydroxide it was soluble, which rules out the idea of calcium ions. So after this you're only dealing between these two. पाउडर माउडर नहीं लिखे, वाइट PPT लिखा करें. पाउडर वाउडर नहीं बनता. Right? Now he's saying third conclusion. What do you mean third conclusion? बताइएगा जी. मेरी तो आंखें जलनी शुरू हो गई हैं. Sir, third point of previous question. Yes, the reaction sheet, you will be given ions. इसके बाद IGCSE भी करेंगे. Okay. Are you a Pathan? Yes. These are the three conclusions. Now, there's no ammonium ion. It's either the aluminum ion or zinc ion. 1, 2, 3. These are three conclusions. Khair. The student adds excess aqueous sodium hydroxide to X, and then he adds a piece of aluminum. What should come in your brain immediately? If he adds a piece of aluminum, it should come, yeah, this is now the test for nitrate ions. And he's saying he adds an aluminum foil and warms the mixture. Ammonia gas is given off. This confirms that nitrate ions were maujood. And he tests it with damp red litmus paper. What happens with damp red litmus paper? It turns. Describe what happens to the litmus paper. It turns. The damp red litmus paper turns blue because ammonia is a base. Identify the negative ion in Xa. The negative ion is the nitrate ion. You figured it out. So negative ion was nitrate ion, and the positive ion is either aluminum ion or zinc 2 plus ion. So what do we clean nichrome wire with? You clean it with conch HCl. You clean nichrome wire with conch HCl. Done? Now, next. Sir, will we be getting qualitative analysis in the paper? Yes, they are given right here, but you should know them by heart, because if you don't know these things by heart, there's no way you can use these tables in the exam. So it's better to know these things by heart so that you could quickly just peek over them in case you forget in the exams. But you should know these things by heart. Now, last questions which a lot of students are scared of. Now, this sort of questions, question 4 is very generic. Question 4 is the most generic question out of them all. It can be done with using basic chemistry and pure logic. बेसिक केमिस्ट्री एंड प्योर लॉजिक आप लोग इस्तेमाल कर सकते हैं. बेसिक केमिस्ट्री एंड प्योर लॉजिक. He says that Q is a mixture of solid magnesium oxide and barium sulfate. Already, what am I noticing here? Magnesium oxide and barium sulfate. Barium sulfate is a salt. Magnesium oxide is a base. And probably in a lot of questions, when they give you two compounds, you're supposed to separate them. And you know how you separate them? Well, one of the compound would show a reaction with something, the other won't, and then you'd just react them with that substance, then you'd filter them out. The solid would be the residue and the filtrate would then be, you would heat it till the point of crystallization and you would get the filtrate, the solid crystals from the filtrate as well. This is as basic as it gets. As basic as it gets. So he says Q is a mixture of magnesium oxide and sodium barium sulfate, and already my mind has started to think, if it's magnesium oxide, it's a base. Barium sulfate is not a base, it's a salt. So probably the examiner would ask me to separate the two. I'd react magnesium oxide with an acid, it's gonna react, and then once magnesium oxide reacts with the acid, I can easily separate the barium sulfate from magnesium oxide, because that would have been reacted with all the acid, and then I just filter it out and barium sulfate would have been obtained. Basic level knowledge. Okay. Now he's saying magnesium oxide is insoluble in water, but it reacts with dilute hydrochloric acid. Even he is telling you that magnesium oxide, it reacts with dilute HCl. What would it give you? MgCl2 plus H2O. Right? And he says barium sulfate is insoluble in water. So they're both insoluble in water. Both are insoluble in water, but one would react with acid and the other won't. So I'd react it with the acid. And he says plan an investigation to get pure magnesium chloride. Magnesium chloride is what? It is soluble. All chlorides are soluble except for LMS, lead, mercury and silver. So already off the top of my head, what I'm trying to understand is I take magnesium oxide, I take barium sulfate, I react them with acid. I know only this guy is going to react with the acid. Magnesium oxide is going to react with the acid. I'm going to get, I'm going to get what? I'm going to get MgCl2 plus H2O, but this MgCl2 will be aqueous, and I'd also have barium sulfate ka solid. What are we going to do? I'm literally going to perform what? Filtration. Barium sulfate would be obtained as a residue, and magnesium chloride would be obtained as a filtrate. And then what would I do? I'd wash barium sulfate with what? I'd pour distilled water over it, or wash it with distilled water to remove residue or to remove traces of HCl and MgCl2, because realize कि HCl भी हो सकता है और MgCl2 भी आपके पास बना हुआ है, ये दोनों aqueous है, they are both aqueous, so barium sulfate may have traces of this guy and this guy, hence I wash it with distilled water to remove any traces of these two, because they are both aqueous. And then this guy would be dried by gently tapping between two filter papers, and magnesium chloride would be poured into an evaporating dish, heat till the point of crystallization, let it cool, and then you dry it with by gently tapping it between two filter papers. That's all done. Now I think how to test that barium sulfate is pure. Please also read this question. So we've done this part, we've done this part, we've done this part, we've done this part. The only part is कि how do you test that barium sulfate is pure? How do we test? जी बताइएगा. How do we test that barium sulfate is pure? Well, for purity, what do? For purity, you test the melting point. So you could say कि test the melting point of this barium sulfate with another barium sulfate solid. You could do anything. You could do anything as long as you're talking about the melting point, right? So what you do is you measure the melting point of barium sulfate that you have obtained with a pure sample of barium sulfate ka melting point, with the melting point of a pure sample of barium sulfate. Done. So that's why would I add nitric acid? He's already told me to add HCl. Right? So what am I going to do? I'm going to add a lot of HCl so that all of magnesium oxide reacts. Done. So what are the, you may draw the diagram, I've already drawn the diagram. So what am I going to do? I'll first, and also use, list down the apparatus needed. Now keep in mind that if you just list down the apparatus, you would melt it, you would take a sample of it, you would melt it, and then you would compare it with you'd measure the melting point and compare it with the melting point of a pure sample. That's how you test for purity. There's no other way. I'd probably melt this guy. I take some sample out of it and melt it and then compare it with a pure sample of barium sulfate. Okay. Now also understand that the apparatus that you write, if you just list down the apparatus, you get shunne. You get 0 marks for just listing down the apparatus. ATP for O-level IGCSE largely same. Okay. So you get 0 marks for just listing apparatus. You have to use the apparatus. So let's start using them, right? First of all, there's a mixture of these two solids, right? So I need to add acid to it. How do I add the acid to it? Well, I'd say add both the solids to a beaker, see, I'm using the apparatus. You can write in points, please, to a beaker and add the acid. How do you add the acid? Well, I'll use a measuring cylinder because I couldn't care about the accuracy. And add the acid which acid? Add hydrochloric acid using a measuring cylinder. You'll ensure that it's in excess, right? So that all magnesium oxide reacts. Ensure that acid is in excess. So basic. Right? And then what happens? Once you ensure that the acid is in excess, so that you tell the examiner, so that all MgO reacts and MgCl2 is formed. And so now in this particular case you wouldn't have traces of HCl probably, because all the HCl would have reacted. So when you filter out barium sulfate, you'd only have traces of MgCl2. You'd only have magnesium ion or chloride ion ke traces, which you would want to remove, hence you wash it with distilled water. Right? Now he's saying, what do? We add, ensure that HCl aqueous is in excess so that all MgO reacts and MgCl2 aqueous is formed. Then what do? Then you perform filtration. Using a filter funnel. And if you draw the diagram for the examiner, even if you don't write using a filter funnel and all of that, he would see the diagram and he would understand कि आपको पता है what you're on about. Right? So using a filter funnel, what happens? Barium sulfate is obtained as residue. Barium sulfate solid is trapped in the filter paper and is obtained as residue. It's obtained as residue. What do? Wash with distilled water and dry it by gently tapping it between two filter papers. And dry by gently tapping between two filter papers. राइट ये एंड ड्राई की जगह ना मैं इधर लिख रहा हूँ ताकि इसको मैं थोड़ा सा इसको मैं स्टेप 5 लिख रहा हूँ. देन हाउ डू यू ऑब्टेन मैग्नीशियम क्लोराइड. हाउ डू यू ऑब्टेन मैग्नीशियम क्लोराइड. और इसकी प्योरिटी कैसे चेक करेंगे, इसका कैसे चेक करेंगे कि इट्स प्योर. टू टेस्ट प्योरिटी मेल्ट barium sulfate or measure the melting point. The melting point of barium sulfate obtained versus the melting point of pure barium sulfate. Yeah. And then how do you obtain magnesium chloride? Pour the filtrate which will have magnesium chloride right here. This is called filtrate. So what we do is we pour the filtrate into an evaporating dish because it's soluble salt other than group 1 na? So you pour it into an evaporating dish and what do? You heat till solution becomes saturated or till the point of crystallization and then you let it cool for crystals to form. You get about 10 marks here. It's a 6-mark question, but I have to do it very comprehensively. So you let it cool for crystals to form, and what happens? Last, you dry it. You repeat step 5. Repeat. That's why step 5 for it. You could write the entire answer in points like I have written, and you will get full marks. Right? You can write the entire answer in points and you will write full marks. Just study the methods written in book. No. You have to use your brain. Yeah. Now, one more thing, guys. This is how you easily solve every single question. Literally. Where did it go? Tuck. What the hell? Why is this? Where is it? अच्छा जी. Done. Easy peasy lemon squeezy. Now one more thing, guys, to understand here is ये वाला एक दफ़ा फिर देखिएगा. ये वाला पार्ट एक दफ़ा फिर देखिए. Soluble solids tend to become less soluble at lower temperatures, right? Solubility कम होती है जैसे कि जैसे टेम्परेचर कम होता है. टेम्परेचर 40 से 0 से 40 पे आया, solubility में चेंज 180 का आ रहा है. द चेंज इन solubility इज ऑफ 180 ग्राम्स. 40 डिग्री सेल्सियस की चेंज में चेंज इन solubility इज ऑफ 180 ग्राम्स. इजंट इट? नाउ अगर तो 180 ग्राम्स 40 डिग्री सेल्सियस के चेंज को रिप्रेजेंट कर रही है, तो 20 डिग्री सेल्सियस का चेंज कितना होगा? इल बी 180 डिवाइड बाय 2. और यू कुड से 40 डिग्री सेल्सियस 180 ग्राम्स का चेंज रिप्रेजेंट करती है, तो 20 डिग्री सेल्सियस कितने ग्राम का चेंज रिप्रेजेंट करेगा? एक्स क्रॉस मल्टीप्लाई व्हाट यू गेट 180 into 20 divided by 40, 1s 2s, you get what? X equals 90. So 20 degrees Celsius would represent a change of 90 grams, wouldn't it? मतलब अगर मैं 40 से 20 पे जाऊंगा तो solubility 90 से कम हो जानी चाहिए. Why? Because the lower the temperature, the more insoluble the solid is gonna become. So क्या होगा? 480 पहली थी, बहुत ज़्यादा थी, लेकिन अब 90 से कम हो जाएगी. Why would it decrease by 90? Why would the solubility decrease by 90? It would decrease by 90 because why? Why would it decrease by? Is my screen stuck? What the hell? Wait, guys. Wait. क्या बकवास है? Wait. Is it still stuck? What the hell? Is it fine now? Yeah. Okay. I was just saying, yaar, 40 degrees Celsius is representing a change of 40 degrees Celsius is representing a change of 180 grams. So 20 degrees Celsius would represent how much change? It will represent 90 gram change. Now you all know that if you decrease the temperature, soluble solids will tend to become less soluble. So 90 grams से solubility कम हो जाएगी. So that's 480 minus 90. That's 390, right? Great. That's all. ये एक पेपर हुआ. It's time to do the next paper. Give me 5 minutes break. And before, why does solubility decrease? Solubility decreases at lower temperature. There's a reason to that. That's not part of your course. वो इंशाल्लाह आप पढ़ेंगे. AS में मैं पढ़ा दूंगा. It has to do with energetics. And also has to do with the idea कि यार जैसे जैसे आप टेम्परेचर कम करते हैं ना, पार्टिकल्स करीब आते हैं, तो वो उतने ऐसे याद कर लें इसको. इफ़ यू वांट नो द वाई बिहाइंड इट. लेकिन जैसे जैसे आप टेम्परेचर कम करेंगे, पार्टिकल्स करीब आएंगे. जितना जितना पार्टिकल्स करीब आएंगे उतना उसमें चीज़ें सॉल्यूबल नहीं होंगी ना. वो तो करीब आ गए, इकट्ठे हो गए, यूनिटी हो गई उनमें, राइट. हाँ, वाई आर वी अस्यूमिंग कि सॉल्यूबिलिटी का कर्व लीनियर है? वी आर अस्यूमिंग क्योंकि बस वही हम कर सकते हैं. इज सेइंग टू एस्टिमेट इट, right? He wants to estimate it now. ठीक है. I'll be back in 5 minutes, guys. I'll be back in 5 minutes. We have officially covered one paper. We're going to do the other at 10 p.m. So I'm going to put a break sign and inshallah we'll meet in a moment. Chalo ji, break. Assalamu alaikum, assalamu alaikum, assalamu alaikum, assalamu alaikum. I'm back with another vlog. Yo, I love this YouTube live. I love this. This is why teachers conducted YouTube lives. बड़ा मजा आता है यार YouTube lives conduct करके. Seriously यार. It's so fun. The only problem is कि यार जो YouTube live का chat जो है ना, everybody can hear me, right? I hope everybody can hear me. Hi. जी जनाब. Guys, please let's focus on the paper. So I write my name. Next paper, Suleiman Khan. And what I've realized is I want to tell you guys something. Suleiman Khan, I want to tell you guys something. Guys, please. देखिए, one more thing that you need to understand for question number 3s. One more thing that you need to understand for question number 3, which is salt preparation. I think something relating to this preparation. I think something pertaining to this may come in the exam, which is the idea कि remember, never forget oxidizing agents and reducing agents, and never forget oxidation and reduction. Never forget oxidation and reduction in such question. It is widely tested in AS level, and I think that because the IGCSE pattern looks more like AS level now, I think that this sort of question may be tested where, let's suppose I give you Fe2 plus, right? And I say what is the precipitate formed when you add sodium hydroxide to it? You'd say obviously it's a green PPT which is insoluble in excess NaOH, right? But then in the next step what I do is I add an oxidizing agent to it. The moment I add an oxidizing agent to Fe2 plus, what's going to happen? You should know that Fe2 plus can go into Fe3 plus and get oxidized. Isn't that true? Just like if I have iodide ions, I can make the iodide ions go into I2. By what? By oxidizing it. Oxidation. So whenever I add an oxidizing agent, it will go from I minus to I2. Similarly, Fe2 plus is going to go into Fe3 plus by losing an electron. So then once you add an oxidizing agent, then you add NaOH to it. Now you're going to see what? Now you're going to see a red-brown PPT, because now Fe3 plus is going to make the bonds with OH minus ions. So please keep this in mind. These sort of things are very important. Please, let's just stop talking about Rayan for a moment and let's focus on the paper. Yeah. Everybody saying kick Rayan. How do we stop the chat? Can we stop the chat? Reactions, participants. Can we stop the chat or something? No, we can't. That's the biggest problem. Rayan needs to lock in. Yes. Sir, Rayan, please guys, please guys. You're O-level IGCSE students, you know. The things that you guys are saying right now is बड़ा ऐसे लगते हैं 2 साल के बच्चे हो यार. Okay, let's start. So, question 1 says, eggshells are made up of a mixture of calcium carbonate and other insoluble substances. Now, if it has calcium carbonate and other substances, do you know how I think about this? I'm like, acha, calcium carbonate is a weak base. So, if I can react calcium carbonate with acid, it is going to dissolve in the acid, and then I can perform filtration, and then I'm going to get other substances right here. Other substances as residue, and calcium carbonate, let's suppose I reacted with hydrochloric acid, just like in this case, I'm going to get calcium chloride right here as my filtrate, right? So these are the things you should immediately start to think. Immediately. Okay? How do you stop the chat? Please, guys, please stop fighting with each other. This is the first time I'm conducting a live, so you know, I'm obviously going to learn these things later on. But for now, let's please focus on our paper, right? So it says the other substances in the eggshell do not react with dilute hydrochloric acid. What that means is that when you add acid to it, calcium carbonate reacts, gives you calcium chloride, H2O, and carbon dioxide. And carbon dioxide, because carbon dioxide is formed, you're going to see effervescence. Carbon dioxide solution में बना है ना, तो effervescence होगी. Now, sir, go to your live control room in YouTube Studio, click edit, uncheck enable tab. I'm gonna open YouTube Studio now. Chalo. Let's open YouTube Studio now. How do we open YouTube Studio? Oh shit, I think I ruined something. I ruined something or something. Guys, I am unable to turn off the chat, yaar. Unfortunately, you just have to roll with it. इसके बाद I'll learn more things and then I'll do these things, right? So he's saying, acha, eggshells do not react with dilute hydrochloric acid, obviously, and so the other substances in eggshells. So you could absolutely obtain them as a residue. Now, says a student finds the percentage by mass of calcium carbonate in eggshell. Now, what am I going to do? Acha, calcium carbonate, say, how do you figure out percentage? The mass of calcium carbonate, the mass of calcium carbonate divided by the total mass of this entire eggshell into 100%. That's how easy it is. Now, how do you figure out the mass of calcium carbonate? It's pretty easy. Once you figure out the residue, let's suppose the total mass that you added was 80 grams. Of eggshells ka total mass 80 grams tha. And the mass of residue, let's suppose, is maybe like 60 grams. Mass of residue, let's suppose, is 60 grams. What does that mean? That means that since calcium carbonate was the only guy which reacted, and that's obtained here as calcium chloride as a filtrate, the other substance's mass is 60 grams. This is exclusive of calcium carbonate. So what do? The total mass minus the mass of these other substances, which is 60. Total minus 60, what do you get? The mass of calcium carbonate. Because is 60 mein sirf calcium carbonate hi to nahi hai, aur to sab kuch hai. So what do? You say, acha, 20 divided by the total mass, which is 80, into 100%. Right? So he says a student finds the percentage by mass of calcium carbonate in an eggshell. A student finds the percentage. I have already taught you how he does it. Now he says figure 1.1 shows the first 3 steps of the method the student uses. Grind the eggshells into smaller pieces. And how does he do that? He uses a mortar and a pestle. Remember, whenever you're dealing with either coffee beans or you're dealing with some big ass solids, what do? You use a mortar and a pestle to grind them. Why? To increase the surface area so that, the rate of reaction is pretty high. Okay? Every student should watch these papers, by the way. Now I think, find the mass of small pieces of eggshell. How does he do that? Well, he weighs it. This is the initial mass of all these small pieces. Let's suppose it's 80 grams, whatever it is. Then what does he do? He adds the small pieces of eggshell into dilute hydrochloric acid and warms excess dilute hydrochloric acid. How do you know that hydrochloric acid is in excess? There are 2 ways to go about it. The best way to go about it is what? Hanji, how do you know hydrochloric acid is in excess? Please don't be selfish. I'm teaching O-level IGCSE, not A-level at this point right now. How do you know it's in excess? Ji bataiyega. Because realize the more you add hydrochloric acid, you're going to observe effervescence. And if I add more hydrochloric acid and there's no effervescence, that means all the calcium carbonate has reacted. So what do you say? It's pretty logical. You say add more HCl, and if no effervescence, that means all hydrochloric acid is, if no effervescence, that means hydrochloric acid is in excess. All the calcium carbonate is used up. All CaCO3 is equal to used up. Done? That's the idea. Now also there's one more way to go about it, but I don't recommend it. The other way is कि यार आप universal indicator इस्तेमाल करें. Why use universal indicator? Because universal indicator is going to give you what? It's going to give you if there's no calcium carbonate, सारा का सारा खत्म हो गया calcium carbonate और सब कुछ खत्म हो गया, and acid is in excess, then it's going to give you a red, orange or yellow color, Roig Biv, right? So red, orange, yellow color. And why do you not use any other indicator? Because realize that indicators work for a specific range of pHs, whereas universal indicator paper works, or universal indicator solution works for all the pHs. But I do not recommend this, even though it may be written in the marking scheme. Don't recommend it. Okay? Now, next guys, the moment this happens, then what will he do? He will filter this thing out, obviously. And the moment he finishes, this is a filter funnel, and on the filter funnel you have a filter paper, and the other substances get other substances are obtained as residue. So this is also effectively an experiment. Why is he using the Bunsen burner? To ensure that the rate of reaction is high. Describe what is seen when calcium carbonate is added to dilute hydrochloric acid because carbon dioxide is being evolved. You see effervescence. You don't say that the solid dissolves, because obviously understand, although this solid will be dissolving, but there are other solids which will remain. So you can't effectively differentiate between the two. So you see effervescence. Effervescence is observed or is seen. Now it says, describe what the student should do to make sure that the acid is in excess and that all the calcium carbonate has re-added. Add more acid, and if no more effervescence, then what does that mean? That means all CaCO3 has reacted. Done? Done. Please don't use universal indicator. Yes, keep on adding acid till there is no effervescence. Bilkul sahi. The student filters the mixture to obtain the unreacted solid left from the action. Draw a label diagram to show the apparatus that the student would use to filter this. What apparatus would he use? He would use a filter paper with a filter funnel. So this guy is a filter funnel and this guy is a filter paper. Done. That's the apparatus, and this would be your solid which will be trapped. But obviously he's just saying just show the diagram. He's not even saying label it, but I'm just showing it for the sake of showing it, right? Label bola, acha label diagram, label bola hua hai, so hence you label it. Done. Next, after the filtration, the student washes the residue. Identify two substances removed from the residue. Well, hydrochloric acid was in excess, so that is going to be removed. And also understand that calcium chloride is being made right here. Calcium chloride is also an aqueous solution, so traces of calcium chloride would also be observed, right? So what do we say? We say, acha, HCl was in excess and you also have calcium chloride. So what effectively do you remove by washing the residue with distilled water? You remove HCl and calcium chloride. Traces of HCl and calcium chloride. Yeah, dilute HCl likh le yaar, jo marzi. Why not repeat and reweigh till the mass is constant? Why will we be doing that? रटे ना हमारे यार, repeat and reweigh till the mass is constant क्यों हम कर रहे हैं? कोई hydrated salt तो नहीं है जिससे हम पानी निकाल रहे हैं? क्या कर रहे हैं? We're just figuring out ये dissolve कर जा रहा है और other. I literally give you an entire idea. Rewind the video. ये idea समझने की कोशिश करेंगे क्या हो रहा है. Please, yeah. It says, after washing the residue, the student dries the residue in an oven, or he can dry it by gently tapping it between two filter papers. The student then measures the mass of dry residue. The masses the student records are shown in table 1.1. Mass of small pieces of eggshell and mass of residue after filtration. See, the difference between these two would be the mass of calcium carbonate. I've already explained why. Kasim, calcium carbonate has reacted. So the other substances which haven't reacted is this, and the mass of the small pieces, the total mass was this, and the substances that haven't reacted is this. So the difference between the two substances is the substance which reacted, which is calcium carbonate. Okay, keep this in mind. यार किसको? Oh, sorry. How do I? ये ले, ये एक तो हो गया, ठीक है. ये ले एक हो गया, ये ले दूसरे को भी हटाएं, ये ले टाइम आउट, ये ले ये. What is the job of a moderator? What is the job of a moderator? What happens if there is a moderator? Literally I've put can okay. किक नहीं किया. कोई मॉडरेटर बनना चाहता है सही से तो मुझे बताएं मॉडरेटर क्या करता है. Then what do you do? 2 minus 0.11, that gives me what? The mass of calcium carbonate, which is what? 2 minus 0.11, tell me. 1.89 grams. So these are the mass of calcium carbonate. Now he's saying percentage by mass of calcium carbonate. It is the mass of calcium carbonate divided by the total mass, which is 2 multiplied by 100%. What do you get? Mass of calcium carbonate divided by total mass multiplied by 100%, that's 94.5%. So effectively egg shell में बहुत ज़्यादा calcium carbonate होता है. Okay. खैर नेक्स्ट, चलो बाद में बनाएंगे मॉडरेटर, अभी नहीं. Question number 2. A student investigates the reaction between acidic solution B and two different solutions of aqueous sodium hydroxide, solution C and solution D, using two different indicators. The student does two experiments. Rinse the burette with distilled water and then with solution C. Why is he distilling it with he's washing it with solution C? क्यों? To ensure कि ये water इसको dilute ना करे, so that solution C is not diluted. The concentration of solution C is not diluted. और अगर ये dilute हो गया तो फिर volume used is gonna be higher. It will be overstated. Volume used will be higher. अगर ये dilute हो गया इसका मतलब इसकी concentration dilute हो जाएगी तो उसका ज़्यादा volume इस्तेमाल होगा. और solution C क्या है? ये एक alkali है, सोडियम हाइड्रोक्साइड है, तो मैं इसके साथ लिख लेता हूँ alkali. Done? Let's just fill the burette with solution C. तो alkali को इसने solutions burette में डाला हुआ है, बिल्कुल. Now he's saying run some of solution C out of the burette so that the level of the solution is on the burette scale. इसका मतलब ये होता है ना कि वो बिल्कुल अगर burette की बीच में कुछ आ रहा हो तो बिल्कुल वो 0.0 पे या आ जाए या एक exact value पे आ जाए, right? So you can accurately read the meniscus. And दूसरी reason ये होती है and to remove air bubbles from the jet. Air bubbles from the burette jet. असल में होता क्या है, from ब्यूरेट की जेट में, जेट इसको कहते हैं, ब्यूरेट का जेट ये वाला पोर्शन होता है, ये वाला साइड नहीं, ये इसको जेट कहते हैं, ब्यूरेट जेट. तो इस जेट में अक्सर बबल्स बनते हैं, तो आप इसको यू रन सम ऑफ द NaOH आउट ऑफ इट सो दैट देयर आर नो एयर बबल्स. रिकॉर्ड द इनिशियल ब्यूरेट रीडिंग. यूज अ मेजरिंग सिलेंडर टू पोर 20. और नहीं बच्चे, डोंट यूज मेजरिंग सिलेंडर. व्हाट शुड यू बी यूजिंग? यू शुड बी यूजिंग ए पिपेट. दैट्स मोर एक्यूरेट. मेजरिंग सिलेंडर इज लेस एक्यूरेट. To pour 25 cm cube of solution B. Solution B क्या है? Solution B is acid. So acid को आपने conical flask में डाला. And then he says add 5 drops of methyl orange indicator and 5 drops of thymolphthalein to the conical flask. Now understand, thymolphthalein is colorless in the conical flask. Because acid में thymolphthalein is colorless, whereas methyl orange is red. So what color would you see initially? You'd see a red color. Why should the flask be on a white tile? To observe the color change more. To observe the color change at end point more clearly. So observe color change at end point more clearly. और क्या होगा कलर चेंज एट एंड पॉइंट? प्रॉब्ली बिकॉज एज अ स्टूडेंट आई थिंक यार मिथाइल ऑरेंज येलो हो जाएगा, ये ब्लू हो जाएगा, येलो ब्लू आपको क्या देते हैं? ग्रीन देते हैं, तो ग्रीनिश होगा. ये स्लोली ऐड सोल्यूशन सी फ्रॉम द ब्यूरेट. स्लोली क्यों ऐड करने हैं? तेजी से क्यों नहीं ऐड कर सकता? सो दैट द वॉल्यूम दैट आई एम एडिंग इज नॉट ओवरस्टेटेड. ओवरशूट ना कर जाऊं, ओवरस्टेटेड ना हो, ओवरशूट ना कर जाऊं. ये वॉल्यूम इज नॉट टू नॉट ओवरशूट, to not to overshoot or overstate the NaOH added or solution C added. क्योंकि ज़्यादा ऐड हो जाएगा, मोर देन रिक्वायर ऐड हो जाएगा, राइट? तो आपको नहीं चाहिए ना कि मोर देन रिक्वायर, तो मैंने ऐड ही नहीं करना. देन he says while swirling the flask, swirling क्यों कर रहे? to ensure that the reactants are mixed, to ensure that the reactants are mixed properly until the solution changes color from red to orange. Orangish बन जाते हैं, great. This is the first end point. यार ये पहला end point है. It says this is the first endpoint. Record the burette reading at the first endpoint. Because they continue to add solution C from the burette to the conical flask while swirling the flask. The solution changes color from orange to yellow. That is the second endpoint. अच्छा ठीक है जी. Continue to add solution C while flirting the color from yellow to green. That is the second endpoint. So yellow to green is the second endpoint. ठीक है जी. Yellow orange to yellow. अच्छा इन सब का क्या मतलब है? We couldn't care less at this point. बस हमने अपना काम चलाना है. हमने ये जो इंपॉर्टेंट बातें हमें पता होनी चाहिए वो लगा ली हैं. अब आगे जाएं. हीसिंग एक्सपेरिमेंट 2 में क्या किया? एम्प्टीड द कॉनिकल फ्लास्क, रिंस्ड इट विद डिस्टिल्ड वाटर, और उसके बाद वो फिर किसी चीज़ के साथ धोता नहीं है. बिकॉज रियलाइज कॉनिकल फ्लास्क में आ गया सा एसिड है. जो मर्जी कॉनिकल फ्लास्क में पड़ा हो, यू डोंट हैव टू वॉश इट विद दैट सब्सटेंस. डोंट हैव ओनली हैव टू वॉश इट विद डिस्टिल्ड वाटर, और कुछ भी नहीं, ओनली विद डिस्टिल्ड वाटर. उसकी वजह यह है कि कॉनिकल फ्लास्क में जो चीज़ भी मौजूद होगी उसके पार्टिकल्स होंगे, और ऊपर से जो चीज गिरेगी, लेट्स सपोज ऊपर से the alkali is being added, the alkali will only react with the acid particles, it will not react with water particles. So even if there are a lot of water particles, it wouldn't matter because the moles of the acid are the same. Moles of acid in flask do not change, मोल्स तो नहीं बदलते ना. आपके जो सोडियम हाइड्रोक्साइड के पार्टिकल्स हैं, दे आर ओनली गोना रिएक्ट विद एसिड पार्टिकल्स. सो इवन इफ देयर आर वाटर पार्टिकल्स प्रेजेंट, it won't make a difference because sodium hydroxide would react with acid particles only, or acid के particles do not change by adding water. Yes, concentration may change, but acid particles तो नहीं बदलते. So the moles of the acid in the flask do not change. That's one thing to keep in mind. ठीक है. खैर वो कह रहे हैं कि एक्सपेरिमेंट यूजिंग डी इंस्टेड ऑफ सी. अब डी इस्तेमाल करें. एक्सपेरिमेंट 1 ये है सारा, फर्स्ट एंड पॉइंट, सेकंड एंड पॉइंट 2 ये है सारा. बताएं जी, रीडिंग्स बताएं. फर्स्ट पे क्या है? 1, 1.5, 1.6. ये इधर है ब्यूरेट. इनिशियल रीडिंग 1.6 है. बताइएगा जी, मुझे कोई बताएं. आई एम नाउ रीडिंग ऑफ द यूट्यूब स्टूडियो. बताइएगा जी. है सेकेंड एंड पॉइंट की रीडिंग 41.0. इसकी रीडिंग फर्स्ट सेकंड एंड पॉइंट की बता दी, फर्स्ट की बताएं 21.2. राइट हियर ये देखें 21, 21.1, 21.2. ये देखें 41. ऑलवेज रीड द लोअर मिनिस्टर. सो दिस इज नॉट गोना बी, यू आर नॉट गोना रीड दिस, यू आर गोना रीड द लोअर मिनिस्टर जिधर लाइन लाई करती है. 40, 40.5, 40.6, 40.7, 40.8, 40.9, 40.9 and 41. right here 41.1, 41.0 sorry, right here. And then experiment 2 में देखें, initial क्या है? 0, 0.1, 2, 3, 4. ये where most of the line lies. So initial reading 0.4 है, 0.4. इधर 10, 10.1, 10.2, 10.2 है. फर्स्ट की, सेकंड की नहीं, फर्स्ट की. देखें ये रीड करना ज़रूरी है. फर्स्ट ये लिखा हुआ है, सेकंड ये लिखा हुआ है, राइट. और सेकंड क्या है? 20, 20.1. 20.1. This is volume from burette to reach the first endpoint. First endpoint क्या है? 21.2 minus 1.6. सिर्फ फॉलो करने हैं. 21.2 minus 1.6. और इसके लिए भी करें, इसके लिए भी करें, जो कि क्या है? 10.2 minus 0.4. क्या क्या आ रहा है? What do you get? 19.6. And what do you get? 9.8. Done. यार कोई मॉडरेटर मैं ऐड कर सकता हूँ? मॉडरेशन एक्टिविटी. ओ ये तो स्टक कर गया यार. शिट, अरे स्टक हो गई. मुझे समझ ही नहीं आती यार. लाइव स्ट्रीम में पहली दफ़ा कर रहा हूँ ना. चलो इसके बाद सही कर लेंगे, क्या ही कर सकते हैं. कैन डू एनीथिंग गाइस. पता नहीं कैसे करते हैं. आई डोंट नो. I don't know यार how to moderate this shit. सारा लैपटॉप ही स्टक हुआ पड़ा हुआ है. खैर, and total volume added from burette to reach, total volume added, एक सेकंड, चैट ही गायब हो गई अब तो. चलो अगली दफ़ा कमेंट्स बंद कर देंगे हैं. अब तो मुझे आहिस्ता आहिस्ता समझ आएगी ना इन चीज़ों की. ये तो फॉर द फर्स्ट टाइम हम ऐसे ट्रायल लगा रहे हैं इस पर. खैर, ही सेइंग total volume added from burette to reach the second end point. second end point कितना है ये. और total volume added from the burette, total कितना था. initial volume ये है 1.6 and second end point is 41.0. so initial से full total volume कितना ऐड हुआ है 1.6 से आ गए 41 पे. तो total कितना है 41 minus 1.6, 41.0 minus 1.6 इस केस में. और दूसरे केस में क्या है 20.1 डिवाइड माइनस 0.4. क्या आ रहा है जनाब 39.4 और 19.7. चलो तो जी हमारे पास आ गया 39.4 और 19.7. डन. एंड ऑल्सो सी व्हाट्स हैपनिंग. डी और सी में कितना फर्क है कॉन्सेंट्रेशन का. सी डी इज व्हाट, दे आर बोथ एल्कलीज राइट. और डी का कम वॉल्यूम इस्तेमाल हो रहा है विच मीन्स डी इज मोर कॉन्सेंट्रेटेड. इसका वॉल्यूम कम इस्तेमाल हो रहा है टू न्यूट्रलाइज द सेम सोल्यूशन ऑफ एसिड. इसका कम वॉल्यूम इस्तेमाल. एंड हाउ मच कम, कितना ज्यादा कॉन्सेंट्रेटेड है. इट्स ऑलमोस्ट ट्वाइस एज कॉन्सेंट्रेटेड. देखिए ना 39.4 cm³ सी का इस्तेमाल हो रहा है लेकिन इसका 19.7 cm³ इस्तेमाल हो रहा है. सो इट्स ऑलमोस्ट ट्वाइस एज मोर कॉन्सेंट्रेटेड बाय द वे. जस्ट बेसिक मैथ इजंट इट. सो ट्वाइस एज मोर कॉन्सेंट्रेटेड है. ये चैट चूट स्टक हुई पड़ी हुई है. चैट इज बिल्कुल स्टक. Guys please यार, you guys are not kids are you हैं. O level IGCSE के स्टूडेंट्स हो यार. अच्छा किधर है यार मॉडरेटर, किसको डालूं यार. कोई मेरा स्टूडेंट है इसमें लाइव क्लास और स्टूडेंट है जिसको मैं मॉडरेटर बनाऊं और खड़काएं यार ये जो बच्चे शोर कर रहे हैं. Damn, this chat is crazy. This chat is crazy यार. पागल बच्चे हैं इधर पढ़ने ही नहीं आए यार. क्या पागल हो गए. ओके चलो जी. चलो बस सही है. आगे बढ़े. Explain why conical flask is rinsed with distilled water at the start of experiment 2. At the start of experiment 2, why is it rinsed with distilled water? Why? To remove impurities from experiment 1. So to remove or to clean it from experiment 1. Done? Or to clean it. Then he says at the start of experiment 1, the burette is rinsed with distilled water and then it is rinsed with solution C. Explain how the volume added from the burette to reach this end point would be different if the burette was not rinsed with solution C. Well, if it wasn't rinsed with solution C, then what would happen? Solution C would become diluted, and so more or higher volume of solution C would be required. Done. Then explain why the conical flask is placed on a wire. Again, we've already talked about it too. Observe the color change more clearly. Observe the color change more clearly or clearly. Compare the concentration of solution C used in experiment 1 with the concentration of solution D. We've already compared them. What is the... oh my god, ये क्या है? हम दोबारा लगाएं. ये आ गया, हम वापस आ गए. So compare the concentration of C used in experiment 1 with the concentration of D. Comparison करें जी C और D में. D is twice as much concentrated compared to C because D का कम volume इस्तेमाल हो रहा है. That's all. Okay. So what do you say? What do you say जी? जी. यार ये क्या है यार? यार वेट ओ चलो जी, एक तो काम. कंपेरिजन ये है कि D इज मोर कॉन्सेंट्रेटेड देन C क्योंकि इसका कम वॉल्यूम इस्तेमाल हो रहा है. D इज मोर कॉन्सेंट्रेटेड देन C, ऑलमोस्ट ट्वाइस as much. ये लिखना है twice as much, right? Why? Because smaller volume of D is used compared to C. Deduce the volume of C required to reach the first endpoint if experiment 1 is repeated using 50 cm cube of solution B instead of 25 cm cube. Reduce the volume of solution C. Solution C का कितना volume और चाहिए होगा to reach the first endpoint if experiment 1 is repeated using 50 cm cube of B instead of 20. B is what? B is acid. तो एसिड को उसने डबल कर दिया. तो एसिड को डबल करने का मतलब क्या है कि क्या चीज़ डबल होगी? इफ द एसिड इज बीइंग डबल तो फर्स्ट एंड पॉइंट के लिए 19.6 cm क्यूब चाहिए था, वो भी डबल हो जाएगा. विच इज़ व्हाट? इधर ये देखें अंदो, ये देखें. द फर्स्ट एंड पॉइंट के लिए कितना वॉल्यूम ऐड हुआ है? 19.6. तो ये वॉल्यूम भी क्या हो जाएगा? डबल हो जाएगा. बिकॉज आपने एसिड बढ़ा दिया, एसिड के पार्टिकल्स बढ़ जाएंगे तो इसके पार्टिकल्स भी डबल चाहिए होंगे फिर. सो 19.6 टाइम्स बाई 2 व्हाट डू यू गेट? जी बताइएगा. 39.2 cm क्यूब. देखिए 2 मार्क का है बिकॉज 39.2 का एक मार्क है और cm क्यूब का दूसरा मार्क होगा. State why using 50 cm cube of solution B would cause a problem when finding the volume of solution C needed to reach the second endpoint. देखिए the first endpoint would require twice the volume, which is what? 39.2. The second endpoint would also require twice the volume. So the second endpoint is at what? The second endpoint कब आ रहे हैं आपके पास? 39.4. तो second endpoint 39.4 पे आ रहे हैं, इसका मतलब है 39.4 times 2. Second endpoint ये 39.4 times 2. What do you get? 39.4 times 2. 78.8. और ये 78.8 cm क्यूब, ये 78.8 cm क्यूब की वजह से क्या होगा? It will exceed the volume that a burette can hold. अब ब्यूरेट कितना वॉल्यूम होल्ड करता है? 50 cm क्यूब, इजंट इट? हमारे कोर्सों में तकरीबन 50 ही होल्ड करता है, राइट? तो कह रहे हैं कि जी वाई वुड इट नॉट बी फीजिबल? क्योंकि 50 cm क्यूब से तो बाहर टप जाएगी. 78.8 पे आप चले गए हैं. सो वी टेल द एग्जामिनर कि यार द रीजन वाई इट इज़ नॉट फीजिबल इज बिकॉज टोटल, देखिए ना, टोटल वॉल्यूम आपने कितना ऐड किया है सोल्यूशन का? टोटल वॉल्यूम कितना ऐड हुआ है सोल्यूशन का? टोटल वॉल्यूम 39.4 ऐड हुआ है. 39.4. तो ये भी डबल हो जाएगा. इसका भी डबल रिक्वायर होगा ना, कि अगर एसिड आपने डबल कर दिया तो इसका भी डबल होगा. सो इट विल एक्सीड द वॉल्यूम कैपेसिटी ऑफ दैट अ ब्यूरेंट कैन होल्ड. Done? Next. A student repeats experiment 2. The student warms solution B. Solution B याद रखिएगा एसिड है. अपने लिए एनोटेट किया करें. Now he is saying यार he warms it before carrying out titration. State the effect if any on the volume of D. Volume of D का warm करने से क्या था? हाँ, rate of reaction will increase. If you warm it, ROR would increase. Rate of reaction would absolutely, most definitely increase, right? Because increase in temperature increase the frequency of collision, blah blah blah, all of that stuff. But please understand कि ये भी ले, इसको भी हम निकालें जी. ऐसे एक एक मुझे नज़र आता जाएगा, एक एक में ये ये right, done. ये लें. खैर, now, so what would the effect on volume of dV, volume of solution D, मतलब कितना आप NaOH और ऐड करेंगे अगर आप वो बढ़ा दें, आप टेम्परेचर बढ़ा दें. टेम्परेचर बढ़ाने से एसिड का टेम्परेचर आप जितना मर्जी बढ़ाएं, क्या कोई फ़र्क पड़ेगा? कोई फ़र्क नहीं पड़ता. देयर इज गोना बी नो चेंज बिकॉज वार्मिंग विल नॉट चेंज द मोल्स ऑफ एसिड, वुड इट? मोल्स ऑफ एसिड या पार्टिकल्स ऑफ एसिड तो एज इज रहेंगे, जो मैंने आपको ऊपर बताया, राइट हियर. Moles of acid, right here, where was it? When I was talking about the idea here, why does it not matter even if you have water, even if you heat it, because the acid particles, the mole of acid in the flask will not change, so it has no impact whatsoever. So what do you say? Effect? No effect. No effect. Explanation: because warming has no effect on the moles or the particles, or the moles of acid, or warming does not change, has no effect. Warming does not change the moles of the acid. Done. State one change to the apparatus that will improve the accuracy of the results. तो apparatus मेजरिंग सिलेंडर ये इस्तेमाल कर रहा था मनहूस. इधर ये देखिएगा, शुरू में हमने बता दिया था कि मेजरिंग सिलेंडर नहीं करने इस्तेमाल. ही शुड यूज़ अ पिपेट टू पोर दिस. वाई? बिकॉज मेजरिंग सिलेंडर ज़्यादा. तो वन चेंज क्या है? यूज़ ए पिपेट. बस यूज़ ए पिपेट. मेजरिंग सिलेंडर हैज़ अ लोअर रेजोल्यूशन. मेजरिंग सिलेंडर ओनली measures till 1 dp. Done. यूज़ ए पिपेट, वॉल्यूमेट्रिक पिपेट लिख लें और पूरी बात लिखा करें. इंस्टेड ऑफ यूजिंग ए मेजरिंग सिलेंडर. डन. टेस्ट्स यू कैन देखें. नॉर्मली 25 CMQ के लिए हम पिपेट इस्तेमाल करते हैं. ब्यूरेट बाहर चीज़ में ब्यूरेट नहीं घुसाना यार. Burette will become, sir, how do you distinguish a curve or a line of best fit? You distinguish, Ahmad, curve of best fit और line of best fit में distinguishing कैसे आपने करनी है? कि अगर ट्रेंड कर्व की तरह बन रहा हो तो आपने कर्व बनानी है, लाइन की तरफ ट्रेंड बन रहा हो तो लाइन बनानी है. बस that's it. Best line of best fit can be a line, याद रखिएगा, line of best fit can be a line or a curve depending on the trend. ट्रेंड कर्व की तरह बन रहा है तो कर्व बनाइएगा, लाइन की तरह बन रहा है तो लाइन बनाइएगा. सॉलिड ई इज अमोनियम सल्फेट. अमोनियम सल्फेट का क्या मतलब? यू हैव द अमोनियम आयंस एंड यू हैव द सल्फेट आयन. व्हाट आर द टेस्ट्स? डायरेक्टली इट शुड बी ऑन योर फिंगर टिप्स. व्हाट आर द टेस्ट फॉर अमोनियम आयंस? हाँ जी, व्हाट आर द टेस्ट फॉर अमोनियम आयंस? ऐड NaOH, heat or warm, and no aluminum foil. No aluminum foil. What is going to have? Aluminum foil should be the test for nitrate ions. What happens? Ammonia gas is going to be released, which turns damp red litmus blue. And sulfate ions के क्या? हम barium ions डालते हैं. How? In the form of barium nitrate. So first we add dilute nitric acid to remove any impurities, and then we add barium nitrate. Barium और impurities कौन से? हम normally carbonate ions remove करते हैं. To remove carbonate ions. To remove और barium nitrate क्या है? Barium nitrate आपके पास barium ions हैं और ये barium ions are going to react with sulfate ions to give you a white PPT of barium sulfate. This is how you test for it. Barium chloride is also right, Rayan Sajid, but barium chloride is not given at the back of your paper. At the back of your paper you have barium nitrate given. Done? As is to the first portion of E, the student adds 2 cm cube of aqueous sodium hydroxide. The student warms the mixture gently and tests the gas produced. What happens? When you warm it, what gas is produced? Ammonia gas. So the gas produced turns damp red litmus blue. Done, Janab? The gas produced turns damp red litmus paper blue. When to use a burette and when to use a pipette? Kira, you use a pipette to transfer things into the conical flask, transfer solutions into the conical flask. Yeah. Then identify the gas given off, it's ammonia gas. We all know that. This is to the second portion. He adds 1 cm cube of dilute nitric acid followed by a few drops of barium nitrate, which means what? He wants to test for the sulfate ions. So barium ions come into contact with the sulfate ions, forms barium sulfate. That's the ionic equation for it even. So what are the observation? A white PPT. You write precipitate. Please don't write PPT. Write precipitate. White precipitate forms. To the third portion, he adds aqueous potassium manganate ions. Remember, potassium manganate changes. If there is sulfite ions, it goes from purple to colorless. There is no sulfite ion. There are sulfate ions. So nothing's going to happen. No visible change. Or you could say the purple ions and you're adding it to a solution. So since you are in O levels and IGCSE, the moment you add a drop of purple to a colorless solution, it turns very pale pink. The purple color just becomes paler. Effectively, it shows a very pinkish color. Right? So because you are O-level IGCSE, if you weren't O-level IGCSE students, I'd make you guys write no visible change. But because you realize that even when you add potassium manganate, this is purple. The moment you add it to a solution, what happens? A colorless solution, one of the purple drops is added to the colorless solution and it becomes so diluted that it gives you a pinkish tinge to it. So you say solution becomes pink. That's all. If you were in A levels, I'd make you guys write no visible change. Okay, next. Carry out a flame test on solid F. Yellow flame is observed. Yellow flame means sodium ion is present. 1 ion is done. Then it says dissolve it in distilled water, then divide F into 3 portions. Now he's going to perform 3 different tests. What are the tests? Let's look into it. So he's saying he added dilute nitric acid followed by silver nitrate. Silver ions are a test for halides. Remember, these are the test for halides. So halides, okay, he says yellow PPT forms and halides give a yellow PPT. Which halide? It's the silver ion when it reacts with the iodide ions. AgI forms, which is a pale yellow PPT. Done. So you understand कि अच्छा halide ion भी मौजूद है. So you have halide ion here and you have sodium ion here. To the second, he adds aqueous sodium hydroxide drop wise until in excess. White PPT forms sodium hydroxide के साथ. White PPT will form किसके साथ? Aluminum ions will also form white PPT. Zinc ions will also form white PPT. Calcium ions will also form white PPT. But he says the PPT dissolves, which means it can't be calcium ion. Calcium 2 plus ion नहीं हो सकता. It's either aluminum 3 plus ion or zinc 2 plus ion because these guys dissolve in sodium hydroxide. But if you add aqueous ammonia to it, aluminum ions, they will give you a white PPT, zinc ions will give you a white PPT, but aluminum ions will then become insoluble in excess. This guy will be the same, soluble. Aluminum ions are munafiq. So he's saying white PPT forms here when you added aqueous ammonia to it, which is aluminum 3 plus ion or zinc 2 plus ion. And then he's saying the precipitate dissolves in excess, which means it is confirming zinc 2 plus ion. So what ions do you have? You have sodium ion, I minus ion, and zinc 2 plus ion. So what are the 3 ions? Sodium ion, I minus ion, and zinc 2 plus ion. Done. Don't write zinc 2 plus. Yeah, zinc 2 plus ion. Sir, why is ammonia produced when a solution has nitrate and is heated with NaOH ammonia foil? Because it effectively is basically you have nitrates and they go into NH3, राइट. नाउ इफ यू लुक इनटू इट, बेसिकली होती क्या है कि रिडक्शन हो रही होती है हर स्टेज पे. वो रिडक्शन आपके कोर्स का हिस्सा नहीं है, सो आई एम गोना स्किप ओवर इट. बट इवन अमोनियम आयंस, दे गिव यू NH3, right? But nobody cares. Last question. It says liquid alcohols can be burned as fuels in spirit burners. The energy given out can be used to heat water in a boiling tube as shown in figure 4.1. ठीक है जी. देखिए बड़ा सीधा सीधा पेपर होता है, बड़ा सीधा पेपर. क्वेश्चन 4 तो सबसे आसान है. क्वेश्चन 4 इज द इजीएस्ट ऑफ देम ऑल. यार लीक पेपर्स की बात करना बस अब छोड़ देना. बस ये आखिरी सवाल करो. माई आईज आर बर्निंग. आई डोंट नो व्हाई बट माई आईज आर बर्निंग. आउट ऑफ दिस क्वेश्चन वील एंड द लाइव स्ट्रीम. देखते हैं कैसे चलता है लाइव स्ट्रीम है. बस अब ये आखिरी सवाल है. लिक्विड alcohols can be burned as fuels in spirit burners. Great. The energy given out can be used to heat water in a boiling tube. अच्छा, करना क्या है? कह रहे हैं इन्वेस्टिगेट कि लिक्विड अल्कोहल में से, इन तीनों में से, विच विल हीट द वाटर द फास्टेस्ट. कौन सा फास्टेस्ट हीट करेगा? बिल्कुल सीधी बात है. मेक श्योर कि वाटर जो आप ले रहे हो, देखें वाटर जो मैं ले रहा हूँ सब केसेस में सेम वॉल्यूम होना चाहिए. वॉल्यूम वाटर का, लेट्स सपोज मैं 20 cm³ वाटर ले रहा हूँ या 25 cm³ वाटर, सेम वॉल्यूम होना चाहिए. सेम इनिशियल टेम्परेचर होना चाहिए वॉल्यूम वाटर का. बिल्कुल वाटर का इनिशियल टेम्परेचर सेम होना चाहिए. फिर क्या करें जी? एसिड आप इस्तेमाल करें. आप इधर इंसुलेशन भी कर सकते हैं इफ़ यू वांट. इसको क्या कहते हैं? इसको क्लैंप एंड स्टैंड कहते हैं. C&S, क्लैंप एंड स्टैंड, नोबडी केयर्स. बट क्या करना है? बस सिंपल सेम वॉल्यूम ऑफ वाटर लें, सेम इनिशियल टेम्परेचर लें वाटर का. और आप जो है लिक्विड अल्कोहल जो है वो कभी एक दफ़ा में एथेनॉल इस्तेमाल करें, एक प्रोपेनॉल, एक ब्यूटेनॉल, और क्या करें? फाइनल टेम्परेचर निकाल. लेट्स सपोज मैं इसको 1 मिनट के लिए हीट करता हूँ. 1 मिनट में जो सबसे हाईएस्ट टेम्परेचर चेंज देगा, जो सबसे हाईएस्ट टेम्परेचर चेंज देगा या हाईएस्ट टेम्परेचर राइज देगा, हाईएस्ट टेम्परेचर जो 1 मिनट में रीच करेगा इन 1 मिनट, उसका सबसे ज़्यादा, वो सबसे तेज़ी से मतलब हीट कर रहा है चीज़ को. बट दैट्स इट. यही सिंपल है. अब इसमें अंग्रेजी डालनी है और तो कुछ भी नहीं है. और 1 मिनट को देखने के लिए व्हाट डू आई नीड? आई नीड अ स्टॉप क्लॉक. लिटरली दैट्स ऑल. ये आइडिया है बस. राइट. सो व्हाट डू आई टेल द एग्जामिनर? मैंने कहा अच्छा, मेजर द वॉल्यूम. और याद रखिएगा ये मेजर करना है. वॉल्यूम ऑफ वाटर कैसे मेजर करेंगे? कैसे 20 cm³ मेजर करेंगे? मेजर द वॉल्यूम ऑफ वाटर यूजिंग, मेजर 20 cm³ ऑफ वाटर यूजिंग मेजरिंग सिलेंडर. अपने से एस्टिमेट करेंगे यार 20 cm³ इस्तेमाल कर रहे हैं, 25 कर रहे हैं, जो मर्जी. एंड ऐड टू बॉइलिंग ट्यूब. इस ट्यूब को हम क्या कहते हैं? बॉइलिंग ट्यूब कहते हैं. फिर क्या करें? मेजर the initial temperature of water और इंश्योर करें कि ये टेम्परेचर सबके लिए सेम हो. इंश्योर इट इज़ सेम इन ऑल एक्सपेरिमेंट्स. क्योंकि मैं चेंज नहीं निकालना ना. अगर टेम्परेचर चेंज निकालता फिर इसकी इंश्योरिंग की ज़रूरत नहीं थी. इट इज़ सेम इन ऑल. बिल्कुल सीधा इन ऑल केसेस. डन. फिर क्या करें जी? अब करें स्टार्ट टाइमर as you start to heat. जैसे हीट करना शुरू करें, स्टार्ट टाइमर. फिर स्टॉप यूजिंग अ स्टॉप क्लॉक ऑब्वियसली. तो लिख लें जी, यूजिंग ए स्टॉप क्लॉक. फिर क्या करें जी? आफ्टर 1 मिनट मेजर हाईएस्ट टेम्परेचर रीच्ड. 1 मिनट में कितना टेम्परेचर रीच हुआ? फिर क्या करें? जिसका हाईएस्ट टेम्परेचर रीच है, हाईएस्ट टेम्परेचर रीच जिसका है इन 1 मिनट, पहले चेंज निकालें ना. हाईएस्ट टेम्परेचर चेंज रीच इन 1 मिनट इक्वल्स व्हाट? हाईएस्ट टेम्परेचर रीच इक्वल्स द फास्टेस्ट. अच्छा, ये एक और तरीका भी इसको हो सकता था. बिल्कुल एक और तरीका हो सकता था कि आप इनिशियल टेम्परेचर मेजर करते और फिर आप फाइनल टेम्परेचर मेजर कर लेते. राइट. 1 मिनट के बाद फाइनल और फिर चेंज इन टेम्परेचर निकाल लेते. जिसका चेंज इन टेम्परेचर 1 मिनट में हाईएस्ट होगा वो भी द फास्टेस्ट. तो आप ये भी लिख सकते हैं कि जिसका, या ये लिख लें और, या ऐसे लिख लें, या ये कर लें कि जी और. स्टेप 5 क्या करें, आफ्टर 1 मिनट मेजर द हाईएस्ट टेम्परेचर इज 5.5 स्टेप में कैलकुलेट द चेंज इन टेम्परेचर। वो आप तब करते अगर आप ओनली इफ स्टेप 2 इज नॉट परफॉर्म, क्योंकि अगर आपने वाटर का इनिशियल टेम्परेचर सेम कर दिया तो फिर तो कोई फर्क नहीं पड़ता ना, फिर तो जिसका हाईएस्ट होगा वही सबसे तेज होगा। लेकिन अगर वाटर का टेम्परेचर आपने सेम नहीं रखा सब एक्सपेरिमेंट में, तो देन यू कैलकुलेट द चेंज इन टेम्परेचर ओनली इफ स्टेप 2 इज नॉट परफॉर्म। और फिर आप क्या करें, 6 के लिए क्या करें, हाईएस्ट टेम्परेचर रीच्ड इक्वल्स change in temperature, the one which has the highest change in temperature equals the fastest। खत्म, ये कहानी है आपकी पूरी। या और शॉर्टेस्ट टाइम, बिल्कुल सर। वाई मेजरिंग सिलेंडर एंड नॉट ब्यूरेट? कस यार देखें, ब्यूरेट या पिपेट इस्तेमाल, पिपेट तो खैर वैसे भी नहीं है, 25 है, लेकिन यार इट्स नॉट कि मैं बहुत एक्यूरेसी चाहता हूँ इसमें से, बस 20 cm क्यूब है, डाल दिया, बट डाल दिया, इतना कोई फ़र्क तो नहीं पड़ता ना। वो तो टाइट्रेशन में है कि बड़ा ख्याल रखना होता है हर एक चीज़ का। है डन, दिस इज हाउ यू गेट 6 out of 6, बस यही है। डन एंड डस्टेड। अगला पेपर करें कि बस एक और पेपर करें कि कल 2 पेपर करें? कल भी मैं इंशाल्लाह यही एक स्ट्रीम कल भी लगाते हैं। सर डू यू हैव, हाँ यू कैन राइट इन बुलेट पॉइंट्स, एब्सोल्युटली यस, यू कैन गेट दिस PDF, आई विल अपलोड इट। हाँ जी, डन, खत्म। सर 142 साल होकर भी मैराथन करेंगे इंशाल्लाह। यार ब्यूरेट मतलब तुक नहीं बनती ना, ब्यूरेट से आप एक बॉइलिंग ट्यूब में पानी डाल रहे हैं, तो ये बड़ा कोई अजीब सी बात है। यू कैन यूज बुलेट पॉइंट्स इन क्वेश्चन 4, बट मेक श्योर कि उसको एलैबोरेट करें। अ लॉट ऑफ स्टूडेंट्स दे यूज बुलेट पॉइंट्स, बुलेट पॉइंट्स आर वेरी दे आर वेरी गुची, बट द प्रॉब्लम विद बुलेट पॉइंट्स इज कि अगर आप मेरी तरह बुलेट पॉइंट्स में लिखें तो मेरी तरह एलैबोरेट भी करना है। सिर्फ ये नहीं कहा मेजरिंग, यूज अ मेजरिंग सिलेंडर, बुलेट पॉइंट 2, यूज दिस, यूज दैट, 0 नंबर मिलते हैं। ठीक है, चलो डन गाइस, आई एम ग्लैड। आसान लगा, ग्रेट स्टफ, परफेक्ट, मज़ा आया, मुझे भी मज़ा आया। अब हम करेंगे जनाब, स्ट्रीम को बंद करेंगे, देखते हैं हमारा पहला स्ट्रीम ज़िंदगी का कैसे गया, एंड लेट्स सी व्हाट बिकम्स ऑफ इट। यार अब आहिस्ता आहिस्ता स्ट्रीमिंग शुरू करते हैं ना हम भी। चलो, टेबल बनाना होता है रिजल्ट्स का, कोई टेबल टूबल नहीं बनाना होता, बस ख़त्म। एक मोर कल कर लेंगे, कल सेम टाइमिंग, टुमारो 8:30 इंशाल्लाह स्ट्रीम लगाएंगे फिर से। ठीक है, चलो, लव यू ऑल, बाय, चाओ, अस्सलाम वालेकुम, अस्सलाम वालेकुम, अस्सलाम वालेकुम, अस्सलाम वालेकुम, बाय।